Section 1.6, Part 2. In the first half of Section 1.6, we talked about our absolute value equations. We looked at taking our two absolute value bars and breaking them down into two problems, one equal to the positive and one equal to the negative. We also recalled that anything on the outside of absolute value bar had to be removed before you could break down your two bars into your two piles that you have to then sort through. So today we're looking at our absolute value inequalities, and it's a very similar concept, except we have inequality symbols instead of equal signs. So it says that the solutions of the absolute value inequality, the absolute value of x is less than 5, includes values greater than -5 and less than 5. This is the compound inequality. X is greater than a -5 and x is less than 5, which we can write as -5 is less than x, which is less than 5. So the absolute value of x is less than 5, means x is between -5 and 5. So for instance, if we were to look at this little graph we have over here, we know absolute value is the distance from 0. Right? So if I'm at 0 here in the middle, and I have that x was less than 5, that means my distance from 0 has to be within 5 units. Now, if I go from +5, 5 units to 0, I can go to -5, 5 units away. And in this case, it said that the absolute value of x was less than 5, which means we're not equal to 5. So if you think about it from 0, you can go to a maximum of 5 units away, but you're less than 5 units away. That means that this is going to be an AND type of problem, if you remember our compound inequalities from section 1.5. Example 4, so solving the absolute value equation where the absolute value of A is less than B. It says, what is the solution of the absolute value of 4x plus 3 is less than 5? So we take a look at our absolute value bars. There's nothing on the outside, which means I'm ready to go ahead and split into my two problems. 2 bars means we have 2 problems. The first one is exactly as it's written. 4x plus 3 is less than 5. My other one, I have a 4x plus 3, but now I have to compare that to a -5. If you remember, we did one positive, one negative, but this time we have an absolute value sign. We have a less than sign instead of an equal sign. That means that if we're going to change the value of that -5 to the opposite sign, we also need to take the opposite sign of our inequality sign. Otherwise, we'd have a really funny looking inequality when we graph those. So the main thing to do is when you're taking the opposite value, you're taking the opposite of the sign and that number. So a little different than our equations where we could just say one was positive and one was negative. Once we go to that negative, we have to flip that inequality sign. And now we have 2 quick, simple inequalities to solve. So we subtract 3. And divide by 4. So 4x is less than, we'd end up with 2. Dividing by 4, 2 divided by 4, x is less than 1/2. We solve out our other one by subtracting 3. So 4x is greater than a -8. Dividing by 4, we'd have x is greater than a -2. Now, I go to my graph. I need a 1/2 and I need a -2. So I'm going to go -2, skip 1, -1, skip 1, 0, skip 1, 1, skip 1, 2. That way it'll be easy to graph a 1/2. And if I have x is less than 1/2, that means I put my dot on my circle at 1, or I put my circle on my line at 1/2. Always start with that open circle. I double check. I cannot shade it in. So I'm going to label that with my 1/2. It says x is less than. Less than means that we're starting to go off to that left-hand side. And then if I look at my other piece, I have x is greater than a -2. So if I go to my -2, and again, we have an open circle. I do not get to circle the color in that circle because it's not an or equal to. And x is greater than -2. So I'd start shading towards the greater than, and we can see that those are going to end up meeting in the middle. So this is an AND problem, which means I could put the x in the middle, put the smaller number on the right and the larger number on the left, and these are both going to be less than type signs. So x falls between -2 and up to a +1/2. The next part says the absolute value of x is less than 5 means that x is between -5 and 5, exactly what we just did. So the absolute value of x is greater than 5 means that x is outside of that interval from -5 to 5. So now instead of being colored to the inside, being an and type problem, that means we start and color on the outsides. So it says you can say x less than -5 or x is greater than 5. So now this time we're going to have an or type problem. So example 5, solving the absolute value inequality, absolute value of A is greater than or equal to B. It says what is the solution of, move this up a little bit. We had the absolute value of 2x plus 6, and that's greater than or equal, to 10. 2 bars, nothing outside that I need to move. All I get to do is go ahead and 2 bars, 2 problems. The first one exactly as it's written. The next one's going to be a 2x plus 6. And if I'm going to change from a positive 10 to a negative 10, make sure that you flip that inequality sign. All right, you're taking the opposite of 10, which means you need the opposite inequality sign. So our 2 bars, 2 problems, let's solve those down. That means that we are subtracting 6. So 2x is greater than or equal to 4. Dividing by 2, x is greater than or equal to 2. Solving down my other problem, subtracting 6. 2x is less than or equal to -16. Dividing by 2 gives us x is less than or equal to -8. So let's go to our graph. On this one, I'm going to count. I'm going to do every other line by 2. So I'm going to start -8, skip 1, -6, -4, -2, 0, and +2. And then if x is less than or equal to -8, I go to my -8 and I get to put a solid circle there because it's or equal to. And x is less than that, so I'm going to extend my arrow out towards the less than and give some arrowheads on the end here. And then I have x is greater than or equal to 2, so I go to my +2, and again I have my solid circle at +2. And this says x is greater than, so that's going to go to the greater than. And I can say that x is less than or equal to -8. The word or, x was greater than or equal to 2. Now here's a little hint. If you are graphing on a number line and you start to graph, say that you're doing like a less than, and then you go and you start graphing another one, and that's also a less than, and it overlaps, we are not going to do overlaps. Either something is incorrect or your final answer has to be simplified a little bit further just to show one inequality. All right, so our summary. I'm going to erase that because you don't necessarily need that. That was just a hey, by the way. All right, so our concept summary tells us our solutions of absolute value statements. So the first one, the absolute value of x is equal to a, is the distance from x to a is x to 0 is a units. So it is just exactly the distance. It's 2 points on the number line because it's equal to those values. The next one says absolute value of a is less than a, or the absolute value of x is less than a, or the absolute value of x is less than or equal to a. That tells us that the distance from x to 0 is less than a units away. So less than means that you're itty bitty, you're small. That means you have a small view. You have a starting point and a stopping point and you're stuck in between. Less than, less, small view, right? If the absolute value of x is greater than a, or the absolute value of x is greater than or equal to a, the distance from x to 0 is greater than a units away. If you are greater than, you're really, really big, which means that you are extending to the infinities, to the positive infinity to the right and the negative infinity on the left. Okay? So the last piece that we have, it says that a manufacturer's item's actual measurements and its target measurements can differ by a certain amount called tolerance. Depending on what kind of item you purchase, it's going to have a certain amount that it's going to say you're getting 8 ounces of chips. Well, you might have a little itty bitty bit less than 8 ounces, or you might have a little itty bitty bit more. A tolerance means that they're tolerant of how many chips you get. It might have a smidgy difference in terms of maybe a little itty bitty bit less or a little itty bitty bit more. And in the end, it kind of balances out to my example of 8 ounces of chips. Don't eat that all in one sitting. You'll have a bellyache. So tolerance, the way to find tolerance is 1/2 the difference of the maximum and minimum acceptable values. So 1/2 means dividing by 2. The difference means subtract the maximum and minimum acceptable values. So they're going to give you two values, the minimum value and the maximum value. You take and subtract those two numbers and divide by 2. Dividing by 2 takes you to the exact middle of those two numbers. It says you can use absolute value inequalities to describe tolerance. So last example of chapter 1, using an absolute value inequality. It says you are cutting pieces of wood to make a table. Each piece should be 4.75 feet, but you will use a piece if it is greater than 4.7 feet and less than 4.8 feet. So it wants to know what absolute value inequality describes the tolerance of the length of the wood. So first thing we need to do is figure out the tolerance. So if we find the tolerance, that means we're going to take the two numbers that they give us and we're going to subtract them. 4.8 subtract 4.7, and then they told us to take 1/2, so we're going to divide that by 2. Well, 4.8 minus 4.7 is going to give us a 0.1 divided by 2, which means if we throw that in a little calculator, we get 0.05. Now that is the difference I can have between the greatest and the least amount of wood, the size of wood that I need. So what that means is I could have the absolute value of X. I want my wood to be 4.75 feet. So the piece of my wood, my unknown, I'm going to take away 4.75. And we're going to say that that 4.75 is what it should be. So if you want to label just to help you when you're looking at these later. So that's what it should be. So X, the size of the piece of wood, take away what it should be, should give us some sort of difference of 0.05. Well, that would have to be less than a 0.05, and that 0.05 was our tolerance. Right? And that's all you had to do was write an absolute value equation. It's just going to be X minus what it should be in absolute value bars is going to be less than, what could the tolerance be? Subtract the two numbers, divide it by 2. That's the end of chapter 1.